In this video, we'll do the integral from 0 to 1 of x squared times the inverse tangent of x. Also, don't forget to subscribe and turn notifications so you don't miss a video. So we're going to think of this as x squared times the inverse tangent of x. We want to do the DI method. So that's integration by parts, basically. So we want to pick something to be differentiated, the other thing to be integrated. We know how to differentiate inverse tangent of x. The derivative of the inverse tangent of x is 1 over 1 plus x squared. Okay, so we need the plus minus because when you do integration by parts, you have the integration of u dv is uv minus the integral of v du, so the minus sign always has to be there for the second one and the even power ones. Okay, we're going to integrate something, so we have to integrate x squared. The integral of x squared is 1/3 x cubed, it's just the reverse power rule. Okay, so now we do these two multiply by each other, and then this is an integral. Okay, so this will be 1/3 x cubed inverse tangent of x, but don't forget to plug in because we have bounds from 0 to 1, and then we have minus the 1/3 we can take out because it's a constant, and we have this, so we have x cubed on the top all over 1 plus x squared. Okay, so let's do this first. So let's evaluate the upper bound and lower bound. Let's evaluate the lower bound first. So if we plug in 0, we get 1/3 times 0 times the inverse tangent of 0. So that's just 0. So let's plug in the top bound. So we have 1/3. 1 cubed is 1, so I'll just leave it. So then we have the inverse tangent of 1. The inverse tangent of 1 is pi over 4 minus 1/3, the integral from 0 to 1. Okay, x cubed. So we could do polynomial division, long division, but I don't feel like doing that today. So let's write this as x squared. So we have x squared times x, all over 1 plus x squared. So now I'm going to think about the x squared as almost the denominator. So that's 1 plus x squared. And we have to minus 1 to get x squared. And then we'll just multiply by x. Okay. So 1/3 times pi over 4, we can multiply the denominators to get pi over 12 minus 1/3, the integral from 0 to 1. So we're going to have 1 plus x squared times x. Okay, so the denominators, the numerator and the denominator will cancel, and you'll just be left with x. And then I'll just do this in parentheses so we don't lose track. Now we're going to have minus 1 times x, so that's minus x all over 1 plus x squared dx. So this is the way to make x cubed over 1 plus x squared integratable without doing long division. Okay, so this is pi over 12. Also, we'll do something else. Okay, so we'll multiply 2 on top, and so on the top. That means we have to divide by 2, or multiply by 2 on the denominator. So we have, instead of 1/3, we have 1/6 because we have to multiply by 1/2. Okay, so we have minus 1/6. The integral of 2x is x squared, and then you're going to plug in from 0 to 1, but at 0 it's 0, at 1 it's 1 squared, which is 1, so we can just leave it as minus 1/6. And then we're going to have minus 1/6 times negative, so that's a positive sign, plus 1/6, times the integral from 0 to 1 of 2x all over 1 plus x squared. So you can do a u substitution, or you can just see that the top is the derivative of the bottom, which is 1 plus x squared. So this will be pi over 12. Let's factor out a minus 1/6 because we can do that. So we're going to have, let's look at this. Yeah, we have 1 minus the integral from 0 to, so this integral, it will be ln of 1 plus x squared. Why? Because the derivative ln of something is 1 over that something times the derivative of the something. So the derivative of 1 plus x squared is 2x on the top, and then over 1 plus x squared. Now we're going to plug in from 0 to 1. So let's plug in the lower bound first, just to see what it does. So this will be ln of 1 plus 0, which is ln of 1, which is 0. And then we have, plugging in 1, we get ln of 2. Okay, good. So this will be pi over 12 minus 1/6 times 1 minus ln of 2, and I made the signs wrong, so this is just, I just multiply by another negative, so it'll be ln of 2 minus 1. And that is the end of the video. Hope you liked it, and thanks for watching.